Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Muhammad bin Ahmad Izwan, PPISMP Mathematics students from IPG Campus Sultan Mizan. So today I will be sharing about my basic algebra continuous assessment, which is Malam, Kilauan, Merdeka, celebration event that highlights the spirit of independence and unity among students. Okay, let's get started with my introduction for my project. So as the head of the Bureau of Culture and Arts, which is Budani of the GPP, so we are planning to organize the Malam Kilauan Merdeka at the Polytechnic Hall. So actually we have a hall which is Bendahara Hall, but it's still under renovation. So we borrow the Polytechnic Hall while waiting for them to finish. So this project, my project, is require systematic planning to solve a problem. So that's why we use the mathematical concept, which are linear equation, inequality, quadratic equation, quadratic inequality, linear programming, and also absolute value. So these mathematical concepts play a crucial role to make sure the project runs smoothly. So for these concepts, two types of tickets involved, which are the VIP tickets and also the regular tickets. So for the VIP tickets represents with X, and also the regular ticket represent with Y. Okay, for the problem presentation, as a leader must consider numerous factors to ensure the event runs smoothly. So the main problems that we face is how to maximize profit while staying within the hall's capacity and the cost limitations. So the main target that we need to target is to maximize the profit, although even though there are a lot of constraints. So by using mathematical concepts, so we can adapt with this problem. So besides, we will determine the total amounts of money collected, and this we will use a linear equation. And so to find the best combination of total tickets sold between the number of VIP and regular tickets to achieve the objective function, and this is involving linear programming and also linear inequality, like the constraints and also the feasible region of the graph that we will plot of this, and also to find the best total number of audience range, and this is about the absolute value, and also to find a total optimum attendees to get the highest profit, and this involves the quadratic function and quadratic equation and also inequality. So this is involving a graph, a parabola graph with maximum points and also two roots that will involve. Okay, moving on to the solution steps. The first solution step, we will focus on linear equation. So X is the number of VIP tickets sold, and Y the number of regular tickets sold. So we have stated that a VIP ticket is 25 ringgit, and also the regular ticket is 10 ringgit. So the total revenue, which is R, represented by a linear equation, which is R equal to 25S plus 10Y. So this equation is show the direct linear relationship between the number of tickets sold and also the total revenue collected. So according to the Polytechnic Hall, we have a maximum capacity, which is 800 audience members, and let's say we decided to target 700 total attendees for realistic ticket sales. So the equation must be X plus Y equal to 700. So from there, we have two related equations, which are 25x plus 10y equal to R, which is total revenue, and also x plus y equal to 700, which is total tickets sold. Okay, let's say we decided to allocate 200 VIP tickets and also 500 regular tickets. So we will substitute it into the formula, which is 25, which is 200 plus 10 and 500. So we will get the total revenue is 10,000 ringgit. So the expected revenue is 10,000 ringgit if the 200 VIP and 5 regular tickets sold. So actually we have a lot of scenarios, and I will give you one of the scenarios. So if the goal is to achieve a 10,000 revenue, so the relationship between S and Y can be rewritten as 25S plus 10Y equal to 10,000 ringgit. So the S and Y it will have a random value. So to find a possible combination, so we assume that X is 300. So substitute 300 into X, so we can find Y. So Y, after the calculation, the Y is 250. So hence to achieve the total revenue of RM 10,000, 300 VIP tickets and also 250 regular tickets also can happen. So it seems that not only 200 VIP and also 500 regular ticket, but in another scenarios we will get any number for S and Y to get the total revenue of 10,000 ringgit. Okay, let's move to the linear equality. So linear equality involved in the constraints for the linear programming graph later. So the first constraint is the hall capacity. So the maximum hall capacity that have been stated is 800. So the VIP ticket, which is X, and also the regular tickets, which is Y, so will be less or equal to 800 tickets. So that's why the constraint of this linear equality is X plus Y less or equal to 800. Okay, the next constraint is the team's coverage. So the total ticket sales should sufficient to cover the cost of the crew payment, like the technical staff, ushers, and also the security teams. So the amount required to cover these costs is RM 1,500. So the VIP ticket is higher returns compared to regular tickets because, as usual, the VIP tickets need the security teams and also more ushers and also technical staff for the VIP tickets. They will focus more on the VIP tickets, more on the VIP attendees. So that's why the linear equalities for these constraints is 5x plus 3y more than or equal to 1,500. Okay, the third constraint is the electricity usage. So the consumption of electricity must be managed to prevent the overloading the systems during the event. So this is very important, so that it will not back out during the event. So the electricity usage for the VIP areas is higher than regular areas because as usual the VIP need more than regular. So there are special lighting, decorative lamps, extra air conditioning, very cool, yeah, the premium equipment, large display screens, and also the charging points at the VIP sections. So the total electricity usage should not exceed 1,000 units to ensure the safety management and the constraints. The linear equality will be 2x plus y less than or equal to 1,000. Okay, the next constraint is the minimum VIP attendance requirement. So the organizer has set a minimum number of VIP guests that must be attend the event. So at least 100 VIP tickets must be sold to achieve the expected level of profit. So it means that if the VIP attendance is not more than or equal to 100, it means that the expected level of profit that we target will be not achieved. So it is important, this concept is very important to make sure that the VIP attendance is more than or equal to 100. So the constraint is x plus x more than or equal to 100. Okay, the next constraint is the audience seats occupation. So to ensure the concert venue is efficiently used, a minimum number of seats must be occupied by the audience. So if they are not occupied by the audience, there will be looking too empty. So they should occupy the space. A minimum number of seats must be occupied by the audience so that they are not looking empty. So regular section represent a larger portion of the seating due to its size or arrangement. So the total number of occupied seats must exceed 600 seats, and the constraint is the x plus 2y more than or equal to 600. Okay, the last constraint is the non-negative constraints. So negative values for seats are impossible, so they should always be positive. Okay, moving on to the third mathematical concept, which is the quadratic equation. So the net profit, which is P, depend on the total number of audience, which is T. So PT equal to negative 0.01 T squared plus 15T minus 5,000. So negative 0.01 T squared shows that when the audience is too large, when the T is too large, costs will grow significantly, and when the costs grow higher and higher, it shows that the net profit will become decreased. So that's why negative 0.01 T squared, and also 15T. 15T is from each audience member contributes an average profit of Rm15, and also negative 5,000. It is a fixed cost from the hall rental, lighting, or maybe performers. So all of this we can conclude that it will form the quadratic functions and also quadratic equation. So the number of audience, which T equal to the number of VIP x plus the number of regular, which is Y. So T equal to x plus Y. Alright. Okay, from the equation above, we can find the break-even points, which is value of T, which is value of total audience when the PT is 0. And the second, we can find the maximum point from the graph of parabola graph, which means the value of T when PT is maximum. This means that the total of optimum attendees to get the highest profit. How many what is the total of optimum attendees to get the highest profit? We go to the break-even points. So we want to remove the negative 0.01 because we want to make sure that T squared is alone without any complex number. So we multiply by negative 100, and it becomes T squared minus 1500T plus 5,000,000 equal to 0. Okay, so using the quadratic formula, which is T equal to negative B plus minus square root B squared minus 4AC over 2A. So we can find two roots that touching the lines, touching the line. So the first T is 500 and the second T is 1000. So since the hall's capacity is 800, so the event is profitable only when 500 when the T is between the 500 and 800. So if the total audience is less than 500, the event will not be profitable as we are targeting. Okay, next we go to the maximum points. So the formula for the maximum points is a negative B over 2A. So B is the 15, and also A is negative 0.01. So after calculation, after substitution, you can get the T maximum is 750. So we can substitute 750 into the formula, so we can get the profit, the total profit, the maximum profit is the 625. Okay, it means that the organizer will achieve maximum profit of RM 625 if the total audience are 750 peoples. Okay, next we go to the linear programming. So this is the list of 6 constraints from the 6 different problem, and the objective function of this linear programming is a 25p equal to 25x plus 10y. Okay, this is what we can get after we plot the graph one by one of every constraints that we stated earlier. So this is okay. After this plotting graph, we can identify the 5 points that we get, which are A, B, C, D, and E, performing the shape of the feasible region colored blue. Okay, we need to identify every points that we get from the feasible region. For example, A, B, C, D, and E. So A is 100, 7 and 700, B 200 and 600, and so on. So every point that we get, we can substitute it into the formula of objective function. So for example, A 100 and 700. So 25 bracket 100 plus 10 bracket 700. So the P, which is the profit we can get, is 9,500. So for every intercept point, we do the substitution, and we can get the profit for every intercept points. Okay, the last mathematical concept is the absolute value. Okay, let's say we target 700 attendees, but the actual total attendees is not exactly 700. So it may be less than or more than 700. It's slightly different. So that's why we use absolute value. So t minus 700 less than or equal to let's say 50. So t actually is actual attendees. So from this we can identify the total tickets that will buy maybe above or below the target of 700. So the equation means the total of tickets sold must be within 50 tickets above or below the target of 700. So by this range, it is acceptable, and the best values for the tickets. Okay, and this is how to calculate how to solve the inequality of the absolute value. So t minus 700 is minus 700. We change the side to the right and also to the left, and after the calculation, we can get the result is 650 less than or equal to t less than or equal to 750. It means the feasible range for ticket sales is between 950 and 750 tickets. So it means that the ticket sales that fewer than 650 or maybe exceed than 750, it means that the target is not achieved. So if we stay in this range, it will ensure the event abide by the goal without the overcapacity and also underperformance. Okay, next we go to the analysis and interpretation. So to achieve the total revenue of RM 10,000, we have two scenarios, which is 300 VIP tickets and 250, and also 200 VIP tickets and also 600 regular. So we have two scenarios, and actually we can get more than two scenarios, but this is an example of the scenario. So okay, but considering that we need to have a regular ticket is more than VIP tickets, thus 300 VIP and 250 regular tickets will not be chosen, and 200 and 600 tickets is chosen, considering that the regular ticket should be more than VIP ticket. So by this linear equation, we can make sure that we can identify what is the best combination of tickets sold for every VIP and regular tickets. Okay, next is about a quadratic equation and also inequality. So we get 500 and 1000 of the break-even points that we get. So by considering that the hall capacity is only 800 students, so the range the sold should be between 500 and 800 only. So by that range, 750 total attendees is the most profitable total attendees by referring to the maximum points. So the maximum points that we got for T is 750, and the profitable that we can get if the 750 total attendees is 625. So this is how we use the quadratic equation and inequality in real life, so that we can identify what is the best choices for the total attendees to achieve the objective function. Okay, for the absolute value of slice on the best range, which are 650 and 750 total ticket sales. So if there are more exceed 750 and also fewer than 650, we will not get profitable as we targeted. So this is how we use the absolute value in our daily life. For the linear programming, so among the 5 intersect points that we get, the highest objective function is the point C, which is 466 VIP attendees and 66 regular attendees, with the objective function is the highest. So although the point C is the highest objective function, it is not the optimum result because 16 regular attendees is not logic. The regular attendees need to be more than VIP attendees, because VIP is usually not that higher. So the regular attendees should be more than the VIP attendees. So thus the point B is the most efficient objective function, with the VIP attendees is 200 and also 600 regular attendees, and the objective function that we got is 11,000 ringgit. So which satisfied the hall capacity limit and also all the 6 constraints that we have stated earlier. And lastly, for the conclusion, so to conclude, the integration of all mathematical models ensures a well-planned, balanced and also sustainable event, and also it demonstrates how mathematical reasonings can be applied to real-world situations to achieve the optimal solutions and fantastic decision making. So every problems in our life, we can convert it into the mathematical concept, into the number, into the equation, so that we can identify more accurately using the number. So the mathematical concept is easily to use. We just understand and remember the formula, so we can calculate it, we can use it to solve problems in our daily life. So I think that's all from me. Thank you for watching my videos and good luck. Bye.